because we now spoke a lot about how we could build a VC fund based on AI, how we can do AI trading. And yesterday we already touched the topic around regulation. What is AI really doing? Do we really understand what's happening there? And this black box of AI, can we actually unbundle it? And I'm very happy that Professor Dr. Beril, I have to read the story, Sirmacek, I hope I pronounced it well, from the Jönköping University in Sweden is here with us. She has done tremendous work in all different fields, industrial fields, but also machine learning, AI statistics, and she will help us shed some light on this topic. I hope you're ready, and welcome, and let's start.
Thank you very much for your nice welcome, and you pronounced my name perfectly. Thank you for that. And good afternoon, everyone. It's a great pleasure for me to meet you at this virtual event, Rise of AI in 2020. I hope it's a real event again next year to meet each other. I'm Beril. I'm a scientist working on computer vision and AI, as I'm very nicely introduced. Thank you very much for that. I'm pursuing my academic career, but besides, I'm developing robust algorithms for industry as well. In both academic work and industrial work, it's extremely important to know what we are doing with our AI or machine learning models and to explain whether we can trust on decisions of these models or not when we are using them either in scientific work or in industrial work. Therefore, we have to develop trustworthy AI, and in other words, we have to know how we can develop AI that we can trust. This is going to be my topic today, and I would like to have a short discussion with you in my short time to address these topics on our human needs, why we seek for trust in all areas of our lives, and our daily needs, but our also industrial business needs of trust, and how can we develop trustworthy AI, or is it possible at all to develop trustworthy AI, and what kind of mathematical tools do we have to see whether we can trust on our model or not. And finally, what's coming next? I would like to have a discussion with you, a little bit brainstorming, including my ideas and imagination, what could be waiting for us in the field of trustworthy AI. We human beings are social creatures. We do not only have physical needs like food and drinks, water, and we also need we also have other needs to survive. And Abraham Maslow in 1943, he's written a paper called A Theory of Human Motivation, and he suggested a very well-known Maslow's pyramid. And in this pyramid, he described human needs for our survival. The largest layer in the bottom corresponds to the layer which we need most for survival, and then their importance are reduced when you go upper, when the slides are getting smaller. And as you see here, after food and water, our humans' basic survival needs are safety, security, and which we can also summarize as trust. Assume that a baby who is born, who can find food and water, but not in an environment that he or she can trust and feel safe, baby will die. And we adults are not different than a small baby, but we are just in little bit bigger bodies, but our human needs are just the same like a baby. Beyond our physical needs, we need to trust in all our areas of our lives, not only close relationships, but also our businesses, when we are collaborating, working together under the same roof. And assume that you're a developer and you want to sell a model or deploy it on a cloud and make money with it, so other people can use and pay you monthly with subscription fee, for instance. This model gives a result. Is it safe to use? Is it trustworthy? Can other people really rely on its decision, what it says? And do they really get what they pay for? And does it also work ethically in ethical rules? So these kind of questions opened up as the field of trustworthy AI. So AI is, we know, already there. I mean, we are already use it. So I've got therefore one good news and one bad news. Good news is that AI is already in all areas of our lives. And the bad news is that AI is already in all areas of our lives. So assume that you applied for a credit card and it's rejected. This comes from a result of an AI algorithm, and you want to know why. Who is going to answer that question? And who is going to explain how this model is given the decision? Is it really ethically rejected or not? Assume that you are in a doctor office and doctor analyzed your CT scans, blood measurements with an AI algorithm, which is already being used in hospitals. And then doctor says only way to cure you is to have a surgery. Can you really trust? You will ask why, how this decision is taken. Somebody needs to explain us how these models are working in order to trust. And let's say you made a job application. You've seen some other speakers in the beginning of the day. I heard job applications are these days are also going through AI models because there are so many applications to scan and select a good candidate. And then decision is taken. And let's say you are not accepted to the position and you want to know why. So the question today is, can we really trust if AI is making decision for us? AI is really regulating all ways of our lives. I will start with some examples of how these models are affecting our lives, and then I will show you some tools that either developers or the business owners or people who want to know how AI is working can use to know whether AI could be trustworthy or not. I start with a story that Latanya Sweeney, she's a nice lady, as you see. She heard an exciting news from her colleagues. Her colleagues said, when we search your name on search engines, we only get some advertisement at site if Latanya is arrested. Get the truth about Latanya. Is Latanya is trustworthy? And they really want to know what's in her story, bringing her these advertisements. And Latanya was a data scientist. She was very curious about what's going on with it. And she wasn't only a scientist, but she was also a Harvard University professor in this area. So she decided to make a good analysis on how these engines are working. And she found out that her name is classified in a Black minority group, which are also in the past associated with some events which ended up with arrestment, and therefore these engines are bringing up results like is Latanya is arrested or not, but not for the other colleagues. So can we really rely on such a model to deploy somewhere and to use? Is it ethical to use? Another issue happened at a police office when they used pictures of the people to decide whether they've got risk to do further crime or not. And this AI model said high risk for Bernard, this is a real story, and low risk for Dylan. And they let both of them go. And Dylan, 3 days later, ended up in police station again, but Bernard had no issues later. So how this decision model is working on? Is it looking at long hair, tattoos, or is it really looking on some facial expressions? It has to explain us what it is looking at, what it is focusing at, to rely on the results at the end. Maybe you heard that examples. People added some little noise on pictures. A pig classification didn't work. It ended up classifying it as something else. Again, a panda is classified like another animal. Just a little bit noise is added. Even human eye cannot distinguish the noise, but this changes the decision. Assume that you're using this computer vision algorithm on a self-driving car, and suddenly the sensor became a little bit dirty and it cannot give the right decision anymore. These were bad working examples. Let's see a nice working example, but still needs explanation. Somebody developed a model of discrimination of wolf and husky, and at the end they saw that the model was working with 99.9% accuracy. And they were really surprised. Wolf and husky look like each other so much. That shouldn't give very high accuracy. Why it's working very nicely? So they also, even if the result is very good, we still have a question whether we can trust or not. So high performance of an algorithm doesn't mean that we can hide the trust. We still need explanation of why we can trust on this high performance. Therefore, there has been many studies of explainable AI, but as XAI, we are hearing it more often in last 2-3 years maybe. Before that, it was mostly called interpretable artificial intelligence algorithms, and it's been searched for almost 10 years at the moment. The idea is we need some mathematical tools. Let's say we've got some training examples, then we trained our AI model, then a new data came from a real environment, and the model, which is trained by training data, gets new example, gives a decision. And what XAI is trying to do to answer why this decision is taken. Then we go to a next step. The next step is to explain this why depending on the audience. So who is asking the question of why? If it's the developer who is asking why, maybe we need to explain it more theoretically about layers, what's going on in these layers. Is there a bias issue? Maybe you need to retrain it this way. But if it's an audience who is the end user, somebody waiting for a bank card, maybe we have to explain the decision-making process differently, either by simplifying the neural network or making more examples from how similar examples in the training set looked like, therefore the decision is taken. So explainable AI algorithms choosing process is really dependent on who is asking the question of why, who is the audience, to whom we need to explain this why. And when we want to explain why, we have developed mathematical tools to decide whether we can trust or not. Well, maybe we can trust by looking at this. We try to get ideas about training data set, about a model itself, and about the input where we are looking at in this input when we are making our decision, in order to explain our model a little bit to open up the data set. I'll just give an example of my own story. I bring my dog to vet, and then vet says, I have to make this vaccine to your dog. And then I ask, why? And then she says, for instance, because every other dog has this vaccine. So then I have an idea whether I can trust on this answer or not. If she explained me differently, I've got this blood report, and then this shows me that this has to be cured with this vaccine. Maybe if it's explained differently, I can trust. So this how it is explained to us also brings us to the point of trust, whether we can trust on explanation or not. And this is never a mathematical thing. I mean, XAI methods are explaining training data, the model itself, where we are looking at input. They are explaining this mathematically, but there is no quantitative value to discuss trust. So the answer that the vet has been given might be less trustworthy for me, but maybe more trustworthy for other person. There's no quantitative issue about trust. This is the end user, the audience must discuss. Nevertheless, we are opening the black box a little bit. We are bringing a little bit transparency by our XAI methods. So opening up the transparency is possible by using some interpretability approaches in the mathematics, and choosing the approach, as we said, depends on the audience, who is asking the question, who is the end user. We have to pick one method of explainability depending on the audience and depending on how much transparency is needed. Does it need to be high level, or does it need to be very detailed? Maybe it's a developer, then we need to explain very, very detailedly. And what problems we are focusing on, what mathematical methods could be used in this development environment, for instance, are possible to be used in this environment, and whether the methods of explainability are used during the training process or after. Maybe model is pre-trained, you got it, but you have to explain it afterwards. So depending on which of these problems are occurring, we have to pick a XAI algorithm. And then the XAI algorithms are also classified as whether they explain the entire model or not, and whether they can split all the neural network layers and to components and explain or not, and whether they are focusing on the how the algorithm is trained or how the algorithm is functioning in real life or not. I listed some mathematical methods which are frequently used, but it's impossible to explain all of them right now. If you are interested, if you're a developer, please pick the slides and you search them further. I will just give you some examples. One of the most used example is sharp or shapely features, which list the feature importance. Then we can decide whether the algorithm, when it's decision making, looking at the right thing or not, or what it is looking at. We've got a Titanic dataset classification example where we classified whether the passenger died or not. Then we looked at the features of the passengers and listed their importance in the decision making, whether he or she died or not. And then we saw that mostly females survived and the males died. So we saw that in all this cabin number, ticket price, age of the person, all these features are looked, but which feature is the most important in that? It's the gender, whether it's female or not. So that explains a little bit how the decision is made, even if it's very high dimensional data set. And this is also applied pixel level to images to explain which pixels are contributing to the decision making. For instance, if the dog is classified as a dog, which pixels contributed to this decision making process? When this decision making process in pixel level is looked to the husky and wolf example that we looked in the beginning of the presentation, they saw that the AI, which was working with 99.9% performance, was looking at the background, and if it sees snow, it was classifying it as a wolf. If it sees no snow, it was classifying the animal as husky. So that's how it was working with very high performance, because all the wolf examples were coming with snow. But it wasn't looking at the animal at all when it's decision making. So high performance doesn't mean that the AI model is working well. We have to use XAI methods to know whether we can trust or not. So AI can tell us, XAI methods can tell us a lot about whether we can trust or not, whether there is a bias or ethical issues in this algorithm or not, and how to fix it. Because if we know how the decision is made, where it's looking at, we can also fix it later. So satisfied customer, satisfied developer, hopefully. What is coming next? These are just my ideas, but I'm just imagining that these AI process will be real time someday. It will be like the AI model will explain to user real time why the decision is taken, and the user will give feedback. I don't trust how you give this decision. Maybe you didn't look at the writing. And then AI maybe retrains itself at that way or looks at other features and then improves the results, maybe gives a new decision and explains again. I'm assuming that this loop will be real time in the future, maybe getting feedback by verbally and improving the model real time. And what we've seen, to wrap it up, simple model doesn't mean that it's low performance, or more complex model doesn't mean that it's high performance. And higher accuracy doesn't mean that we can trust more. We still need to explain why this high accuracy is taken. And XAI at the end comes with both advantages and disadvantages. It might also end up with some security leaks, of course, if we explain something which doesn't need to be explained at that point. So that's all for my presentation, and thank you very much. I hope you reach me on website, on Twitter, on my newsletter, YouTube, and very nice to meet you here. Thank you.
Thanks a lot, Beril. Very much on time. I can see you're a researcher. I guess we will have some questions from the audience, but maybe let me start by a first question. What do you think will be the main drivers in the future for understanding, or the need to understand AI? Is it the regulation that you see, or is it really more understanding the outcome of the models better, training the models better, maybe creating better products out of AI models?
Creating better products, I would say, because in AI, at this moment, we've got generalization problem. We are training algorithms with a data set, then we want to sell the product to somewhere else where it sees totally different data set that we even do not imagine, and we expect the algorithm to work. Then if it's not working, we need to explain why, what it was looking at, why it was working good in this place and not there. Let's assume that a self-driving car, which is developed within Germany, with all examples taken in Germany, all houses and streets learned for Germany, and you sold the car to the place just in the Netherlands, I mean neighbor country. I tell you that it will not work with the same accuracy, because our buildings are all red color and all different kind of cycling roads, and it will not see the same data set. So it's important to know by developers when we are making decision, how we are making decision, what it is looking at, and is it trustworthy or not.
Yeah, I once learned from Tesla that they roll out, I think, their models in several areas at several times, because exactly what you just said. Our friend Fabian has a question. He might be in the room. It seems like he wants to start with an explainability test, and he wants to understand what technical expertise does he need for that. Maybe he should be a student of you.
Well, it depends on the audience, we said. If the audience is a person who wants to know how the algorithm is making decision, we can use methods which either simplifies the decision making process. Instead of showing the 100 layers of neural network, it can be shown by a simple decision tree. I looked at this, then I looked at this, then I looked at this, and this decision is taken, just to simplify the model. We can use such methods, or just like the feature importance, which features were important in this decision-making process. For instance, you applied for a job and you're rejected. Maybe somebody can use this feature important test and say that your publications were not enough, therefore you are rejected. Maybe the feature importance in that case could be helpful. But if you're a developer, then we've got a different story. You have to maybe explain in deeper levels. Maybe you have to really see if it's finding a wolf, if it's really looking at the animal, if it's really looking at the fur, not the background. Then how can I rearrange my training set So it can learn that even if there's no snow on the background, so it still recognizes the animal. Maybe you have to do some tricks in your training process. So depending on the audience, the methods and the explaining ways could be different, but the purpose is to communicate with anybody. If it's someone who doesn't know any programming, we still need to be able to communicate with XAI tools. This was what we were looking at when we are making this decision.
He might call you tomorrow. Be careful. There is a question from Eberhard Schnebel. It's actually also from Fabian, but Eberhard Schnebel had a question to that. How can regulation be technically implemented? More like a TÜV or a GFPR, self-responsibility, or like an inspection standard? So how
This
do
is
we
a
make it
tough
work?
question, and I believe it's still open question for all Europe at the moment. We've got some local teams, national teams, and also teams collaborating Netherlands and Germany, all also collaborating within all Europe to try to decide what are the ethical rules. And how to regulate those rules, and how to describe even the word trust. How do you describe trust? It's too much personal, and these are not mathematically described values. So we are still trying to define these
I think it's also
agreements.
interesting if you look at the level we think the AI should work. We discussed it for accounting automation, and we had an AI that was much better than the human being, but the mistakes were different. So you are better than a human being, but your mistakes are weird. And I guess the same can happen with autonomous driving. So that actually the car is much better, but then it runs over a child. So obviously that's something we don't want. So how do you define that well? And when you look more at the training of a model for explainable AI, is it then possible from your point of view, because that's something my startups really care for, to say, hey, the model is not working, we have bad results, we can't build a good product, we are missing this specific type of data, we are missing this specific type of, I don't know, feature engineering approach, and then we can make it happen. So do we actually get
Definitely.
predictable models?
Definitely. This XAI story started with military in America. So DARPA project in United States has started XAI developments because they were trying to classify camouflage tanks with a vision algorithm, and then they ended up with an algorithm to classify camouflage tanks with 99.9 performance. Again, it was almost working perfectly, and then they asked the question, how this can work this well? I mean, even the human eye cannot see this camouflage tank there. How the AI can see it? This is how AI story started in the beginning. Then they found out that in the AI, they found out that in the training data set, all the camouflage tank examples were taken in cloudy scenes, and all the rest of the images were taken in bright scenes, and the AI model was looking whether there's cloud or not. So it was nothing related to a camouflage tank again. And this is just like the wolf and husky story, but this is how the XAI developments have started. And then they figured out we don't trust on performance numbers. It might say 99.9 performance, but we also need something else. Maybe we need less performance, but we need some explanation. Then we can decide whether we can trust on it right now or not. If the self-driving car is telling us, now I'm driving and giving the decisions myself, but at this moment it's getting dark and I don't trust my decisions a lot. Maybe we can drive a little bit more carefully and share the attention with the car. But if we've got some values about how much the trust car has on itself at that moment, maybe we feel a little bit more relaxed to change the radio and a little bit become drive more relaxed in that point.
Yeah, getting here in a traffic jam, I also felt like self-driving cars would be amazing, so I can just relax and don't look at the traffic. Thanks a lot, Beryl, for your time. Thanks for all your insights, and maybe I posted your website in the chat. Maybe some people can ask some questions and reach out to you.
Thank you very much. Very nice to speak to you, and hope to be there again later. Bye.
Great.